The molecules methyl isonitrile and acetonitrile have the same molecular formula, C2H3N. However, they differ in the bonding arrangements of the atoms. They are examples of isomers, compounds with the same molecular formula that are not identical. Isomers that have different bonds or differ in the locations of bonds within the molecule are called configurational or structural isomers. Methyl isonitrile and acetonitrile are examples of structural isomers. So also are thiocyanic acid and isothiocyanuric acid. Structural isomerism is very common in organic chemistry. For example, consider the isomers of butanol with molecular formula C4H10O. Normal butanol or N-butyl alcohol consists of a straight chain of 4 carbon atoms with the OH group at the end of the chain. In the isomer that has the common name isobutyl alcohol, the carbon chain is not straight, but has a methyl group bonded to the central carbon of a 3-carbon chain. The alcohol group is still bonded to a carbon at the end of the chain. In secondary butyl alcohol, the OH group is attached to one of the 2 inside carbon atoms in the 4-carbon chain. In tertiary butyl alcohol, the OH group is attached to the central carbon atom, which also contains a methyl group. The 4 butyl alcohols differ in their physical and chemical properties, for example, in their boiling points. Isomers that have the same groups of atoms bonded to one another, but differ in the spatial arrangements of the atoms, are called stereoisomers. In geometrical isomers, the groups are arranged differently with respect to one another. A simple example is cis-strands isomerism, about a double bond in alkenes. Because rotation does not occur readily about the carbon-carbon double bond, cis and trans 2-butene are distinct compounds with differing physical properties such as boiling point. Cis-strands isomerism also exists in coordination chemistry, as in this example of cis and trans tetramine dichlorocobalt 3 ion. Optical isomers have the same groups of atoms arranged in the same relationship to one another. But because the molecule lacks a center of symmetry, they are not superimposable upon one another. Optical isomers are mirror images of one another. This example shows secondary butyl alcohol, one of the geometrical isomers of butanol. Notice that all 4 groups attached to the central carbon are different. As a result, the molecule in the foreground is not superimposable on its mirror image. The 2 optical isomers are distinguished by the letters R and S. Molecules such as this are called chiral.